and do my own intro as well. My name is Joshua Eldridge. I'm a senior ecologist and director of ecological services for Matrix Design Group. And as Brad mentioned, this year he avoided the prestigious last presentation of the conference, and fortunately the conference committee selected me for that honor, and I really appreciate the opportunity to speak with you all. I do apologize to my engineering buddies in the audience. I think I found a cheat code. I put hydrology and watershed in the title of my talk, and they let me talk about ecology. Who knew? Who knew? So I'm going to talk about urbanizing watersheds. So we've talked a lot about messy streams. We've talked a lot about how to integrate nature-based designs. We've also heard the term natural infrastructure, right? All of these things, when put into an urban ecosystem, have different challenges. And so I just really thank the committee for letting me talk about this. And I apologize to you guys because with all of the ideas that have been shared these last 2 days, I'm probably going to go off script. So I'm going to do my best, though, to integrate as much as we've heard and put it in context that a lot of my urban engineering partners here and ecologists can relate to. So specifically, we're going to talk about Sterling Ranch. And for my talk today, I'm going to think about like a diamond, right? I'm going to start in talking about the site. We're going to zoom out to think about things like philosophically, really, about the importance of nature and urban ecosystems and how urbanization affects that in our urban waterways, and then zoom back into the site. We're going to talk about a couple different phases because, you know, the lesson or the theme of this conference is learning from the past to invest in the future. And we adapted both our design, our construction approaches, as well as our vegetation management through the course of this project. So this project started in 2018 and is still going today in terms of the adaptive management pieces. So for those of you that are not familiar with the Denver metro area, or Sterling Ranch specifically, it is south of Chatfield State Park in southwest Denver. Specifically, we're looking at phase 2 and phase 3 of Sterling Gulch. And one thing that's really interesting about Sterling Gulch is this is the area that, for those of you who remember when the Colorado Supreme Court allowed us as homeowners to have rain barrels on our property, the rain gauge and stream gauge that was utilized for that court case was in Sterling Gulch. So that's a story for a different day, but that's one thing that I find fascinating about this project. So Sterling Ranch is a planned development. They, at full build-out, are going to have over 12,000 homes, and that is a lot, right? But we are in a housing crisis. There is a shortage of homes for people. So we do need to be thinking about how do we provide homes for people, and how can we do that mindfully so that we can balance out that need for homes with the ecological benefits that we as society get from having access to nature and functioning streamways. I forget who it was. I think it was Mary Powell earlier today was talking about how the Mile High Flood District talks about these systems as stormwater conveyance systems, right? We got to get that lexicon out of our mindset, but really that's what we're dealing with in a lot of these development scenarios. So because of that realization, Mile High Flood District has developed what's now called the Development Improvement Program, wherein they partner with these developers to really help take some of the burden off of those developers in helping establish functioning stream and flood improvements. So because we know that developers don't always do a great job when you're thinking about the complex systems that we are dealing with. We heard a lot over these last 2 days about the hydrology, hydraulics, geomorphology, vegetation, community values, right? These are the 5 pillars that are the foundation of the urban stream framework that our good friend Brian Murphy and others at the district have helped develop. So how do we do that through these partnerships, and the Mile High Flood District really led that program. Matrix Design Group was selected as the design engineer, and then Naranjo Civil Constructors was the GC along with Western States Reclamation. So as we zoom out from Sterling Ranch, I really want to sort of put this in the context of the development framework, right? And the idea that no single raindrop believes it's the cause of the flood, right? So when we look at Highlands Ranch in the 1950s and look at it over the course of just the last 30 years, I guarantee you that each one of those developers did not think they were the cause of the flood. But in reality, the watersheds of Highlands Ranch have suffered significant impacts to those watersheds. And so as urbanization takes place, we, along with the increase in impermeable surfaces, changes the frequency and the intensity of those storm events. We changes in sediment load, stream temperature, but then we also have that decrease in vegetation. Brad's talk was perfect. Even though he was looking at a lot of those stream systems that are more rural or mountainous, less impacted by the urban systems that we have, all of the takeaways that he had, I would recommend as well. The side channels get a little complicated in these urban systems, but the inundation area, like all that stuff is really, really important to think about. So because those influence the functions of these systems. And as a society, we gain benefits from having functioning ecosystems and the ecosystem services associated with them. And I obviously put this in the context of these developments because our Elon last night mentioned that one of the monumental moments in his life was when he was in 3rd or 4th grade and he was playing in a rainstorm, right? Nature was his front yard. And as we as society continue to have more and more people living in urban systems, we need to have access to nature. Nature should not be a wildland experience, right? We shouldn't have to go to a wilderness area to be able to connect to nature, to connect to something bigger than us, and receive the benefits from just walking outside, right? Before my talk, I've made sure to go down to the stream here and just like get that moment of like stress relief, right? Like if more people spent more time outside, we would have different problems in our society, in my opinion. There was a study by the EPA in the late 90s that found the average American spends 87% of their time indoors. In the 90s, the average American spent 87% of their time indoors. That is mind-blowing to me. So I've kind of made it my mission a little bit to make sure that we have an opportunity to have access to nature as often as possible. I really want to have higher functioning, lower maintenance systems so that people can enjoy the benefits of nature without having to travel 2 hours to Avon, right? Mobility is changing in society today. So if you can get access to a functioning stream right out your back door or down the block, I think there's significant benefits for that. So for this project, zooming back into Sterling Ranch, and I apologize, this is the last talk again. I'm going to try and go fast, but I really wanted to hit those moments because my engineering buddies are about to lose their mind here in a minute because I'm only going to talk about soils and plants. But our objectives of this project were really summarized as creating that higher function, lower maintenance channel with an understanding of the changing hydrology from that increased urbanization. There's a couple other nuances within the specific objectives there, but that's really what we were trying to achieve. So this is about advances I'm going to get in hydrology for you guys. So Sterling Gulch has zero base flow. Modeled, we are anticipating about 242 CFS bankful and almost 1,200 CFS at that 100-year, and that is at full build-out. This channel, in total, this isn't the entire reach, but you can, it's about 1,500 linear feet. And just so you guys understand some terminology for some graphs coming up, inside this dotted line is what I call the floodplain, and then we have the slopes. And you can see we have, there's a multi-stage channel, mostly constructed with A-veins and a step pool system. The channel originally, though, was quite in size, and we had about a 10-foot head cut at one point in the channel. And so we had to actually fill quite a bit of that to raise that channel invert to match up with, there's a public easement right-of-way right down there that we had to tie into, and a future road that was going in at the bottom there, so we had to connect A and B, right? So, but we really wanted to avoid having to over-armor the system, and we really want to utilize vegetation as the main point of stream stability. So we really need to understand that existing plant community, because noxious weeds, this area had been historically overgrazed. There was a really deep seed bank of noxious species, and so anybody that's worked with me knows that soils are really fundamental to my practice, and really understanding that, because that really does help that the vegetation align with the site. This is an entirely non-irrigated location, so that also has its challenges. So one of the challenges that we had with this project is, because it is developer funded, they were trying to find places to cut costs wherever possible. And so they utilized their contractors to do the side slopes, and then Naranjo Civil and Western States came in and did the floodplain. Not all contractors are created equal. So some of the nuances that we had on those slopes were lost by the speed of some of the contractors that were utilizing, that were doing that work. So during construction, I was fortunate enough to be included in the construction oversight team, and so you can see there's a lot of grass there on that slope, and everybody was like, yeah, we got grass going, we got grass going. And I go out there, and I dig around, I'm looking a little closer, and all of that is jointed goat grass, which is a List B noxious weed. It is an annual grass, and so midstream, no pun intended, we changed our soil strategy. Originally, we had included 1,000 pounds per acre of biosol, 721, and just 100 pounds of humate. And when I wrote that spec, I was like, oh man, this could bite me. Because if you use too much nitrogen, that is a recipe for annual grasses or noxious weeds in general to take over. And I think I'd been talking to too many landscape providers. Like, you see some recommendations of like 1,500, 2,000 pounds per acre of product. 4,000 pounds per acre of product I saw recently. So I must have been swayed by them at that point in time, and so that's how that got in there. I'll admit my mistakes. But once I realized what was happening on these slopes, we changed it. We eliminated the biosol entirely and just used 250 pounds per acre of humate. And the reason I tell you that is because, again, we're changing our approaches here, right? We're learning from the past, and we're trying to influence the future, and I'm really glad we did. So this project, again, was designed in 2018. Construction was completed winter of 2019 going into 2020. We have not received an annual precipitation year since this project has gone in. And so we're fortunate that we had the timing when we did, but available moisture has been a real challenge. So as we dig into the plant data, there's a lot going on here. I don't know if those people in the back of the room are going to be able to see this. The main thing you want to pay attention to is the dark green is our native perennial species. The red is jointed goat grass, yellow is cheatgrass, and then the orange is other non-native annual species. So in those areas where we had the higher nitrogen availability, we had much more annual species. Where we changed it out and just had the humate, we have much higher cover by native perennial species. So that was good. But those side slopes were a problem. The cheatgrass and jointed goat grass were not going away. And so the first year, we tried to mechanically control it and just knock down all the seed heads, try and get it out of the seed bank as much as possible. Those landscape providers that I was telling you about introduced me to a product called Nutrifix. It is a 000 fertilizer, which is basically just boron that they say is will control annual grasses. So it's one way that Boulder, for example, might be able to utilize a pre-emergent without having to call it an herbicide. So we did a test plot, and we compared mechanical controls to Nutrifix. And we were a little late getting it installed the first year, 2021. So we didn't see a huge improvement in 2021, but this last year we saw a significant improvement. Dramatic reductions in the both the annual grasses, the jointed goat grass and cheatgrass, and significant improvements in those perennial native species. But you'll notice there's almost no difference between mechanical or the Nutrifix. I wish I had a control, but there's no way I was letting any part of this site just go to cheatgrass for the long term, because we were really trying, when we are utilizing a system where vegetation is one of the main ways for channel stability, you cannot let annual grasses dominate your landscape, because there's very little soil stability with those types of species. So, so for land managers, owners that are in the room, that's one thing to keep in mind. The cost considerations between these two treatments, we had a crew of about 8 guys out there for 8 hours a day. It took almost 2 days to clear the whole site. So for the test plots, it was less than that, but that's about what it was. And I think it's about 6 acres is the total slope area. And so roughly per treatment, it's about, if you assume $20 an hour, it's roughly like $3,400, I think, per treatment, something like that. Don't hold me to that math, it's rough, okay? And then the NutriFix is about $850 an acre. So, so there's a little bit of cost comparison for you. As we look at it over time, we've continued to see an increase in overall native vegetation. So patience is one of the keys to these non-irrigated channels, because it will take time and persistent maintenance. The soils, the main thing I wanted to show you is that boron is still elevated, even 2 years after application, so we do anticipate there being some long-term effect of that treatment. So here's a couple of photos just showing what it looked like before and what it looks like today over time. Another round, and then a couple of pictures of our structures, our in-stream structures. This is following a pretty significant storm event that happened earlier this year, mid-August. We don't know the exact frequency event that this might be, but we know it was above a 2-year event. So over 250 CFS through here. So you can see overall the channel has stayed relatively in place. There's obviously some soil displacement. One of the challenges, I think, with a channel like this where there's no perennial flows is that only during storm events are these structures tested. And so you see some preferential flow pathways being found around some of these structures, some piping that's taken place. So there's been some regular inspections and maintenance that's had to take place, but overall everything is holding steady. So as we moved into phase 3, it's a much smaller reach, smaller projected hydrology. Because of the challenges we saw with the soils, we adapted and changed our approach again, and we actually scalped the topsoil. It could be used elsewhere, and we wanted to eliminate that seed bank. And then we just amended the existing subsoils in place because we weren't filling a lot, we weren't changing the overall grade a lot, and so we were able to keep our grading pretty simple. We used the same sort of approach, multi-stage channel, A-veins, step pool system, and then we utilized Richlawn 363 with mycorrhizae and humate actually at 200 pounds per acre. So we really only have 1 year of data for phase 3, and you can see that there is very little cheatgrass, annual non-native species or jointed goat grass. And relative to the first year of phase 2, our natives are almost the exact same. So that approach did work. I would not recommend it for all projects, though. Very specific situations where you'd want to scalp and bury your topsoil, because that is a very limited resource in Colorado. So only in this case where we tested it, we did try this approach for a watershed just a little bit further west at Sterling Ranch, and it kind of worked. And I say kinda because what ended up happening, oh, this is phase 3, so I'll go back. Before I tell my story on Willow Creek, let me just check my time real quick. So soils, what we found with that scalp is that the plants used up a lot of our available nutrients. And so we ended up this year, this fall, going back and adding some more fertilizer to the system, just to try and give those plants a little bit of a boost now that we know it's not dominated by noxious species. And so this photograph is from, you can see this same house in that picture, and you can see how much improvement we have in those grasses. Those are almost all entirely native perennial species. So we are seeing really pretty good success now in both phase 2 and phase 3. There's definitely still some work to go, but we are definitely tackling these systems, and you can see how close these houses are, right? And so that, thinking back to the idea around kind of letting the river do the work, right? These messy stream systems, that I would love to be able to test that in these sort of scenarios. And if anybody has a line on a developer that's willing to take that chance, please let me know. But that's my next mission, is like, all right, guys, what can we do here? So some of the key lessons that I want to take away, want you guys to think about as you take away from here, and this is a shameless plug, having a ecologist as part of your team, right? Everybody on the construction team, the engineering team, when they saw grass on that hill slope during construction, they were going bananas, right? They were like, yeah. And it took the nerd in me to ruin that party and be like, that's actually not a good thing, guys. But in most cases, that wouldn't be recognized until it was too late. Patience and persistence. Plan for 3 to 5 years of monitoring and routine maintenance for a lot of these projects, especially if it's non-irrigated. It's going to take time. And in these development scenarios where we have an instant gratification society that is expecting bluegrass lawns in these cases, that messaging has to be through the developer, the county plan review, the engineer, like everybody that's involved in the team needs to understand the sort of the time frames that we're dealing with here. Know your soils early in design, but don't just stop there. Pay attention to your soils during construction. Once you turn that dirt over and it's exposed to air and water, that chemistry can change. So pay attention to that. The seed bank definitely can have an influence on how well that establishing plant community can come in and provide the services that you hope for. And what we're finding now too, and this is probably something that a lot of people don't think about, but the fires have had a significant, and the drought have had a significant effect on the quality of the seed available. And we're seeing more contaminated seed lots. And I think that's what happened. I can't confirm it because the seed provider won't provide me with the seed lot analysis because I didn't buy the seed. But I'm 90% sure that we had contaminated seed on our Willow Creek project where we scalped the soil. So it should not have been a seed bank at all. And we have cheatgrass and we have other annual species. So, so anybody that's out there that is reviewing seed mix submittals, ask for the seed lot analysis as part of that submittal to understand what other contaminants may be in your seed mixes, because that can have a big influence on that resulting plant community. And then adaptive management. Physical labor right now is really hard to get for landscape maintenance. So really consider herbicide usage and how well that can help you maintain your landscapes. But be very wise about what you're using, right? I'm not an advocate for going out and just spraying everything, but it needs to be a tool in our toolbox. Pre-emergence can have a long-lasting effect so that you're not having to go out frequently to try and control those annuals. And then I didn't touch on this at all in our talk, but one thing that we changed too for phase 2 and phase 3 is phase 2 we had erosion control blanket on all those slopes, but then when we had to go in and do all the maintenance because there was a section of the slope that failed, you have to rip out all that blanket to start over. But if you use hydromulch, it's actually much easier to go in, make the changes, it saves you costs. So just things to think about. It's not always a viable option, but something I wanted to put out there because those are some of the ways that we adapted our projects as we move through. So, so with that, I'll take any questions, or if you're all ready to hit the bar, we can skip questions and you can find me there. Yeah, Jeff. So let me go back to that figure. We included seed mixes. So we use an approach that we call stocking the shelves, and that's actually a phrase that Dr. David Buckner developed. And so we have developed seed mixes that include species that would be more hydric in nature. So they would be able to, they're already in the seed bank, so as the hydrologic conditions change, they should be hopefully available in the soils already. Right now, there's not a plan to come back and then like do willows or anything like that. On Willow Creek, where there is perennial flows, we did do more container stock material, and we are seeing that groundwater connection that Brad was talking about, and Icon's drone division flew it recently, and you can see a perfect, like you can just tell where the groundwater is through that system. So I'm changing subjects on you there briefly, but we did consider how that might happen over time, but it's all seed, so we're hoping that it's in the seed bank, and as those hydrologic conditions change, it will change with it. I don't remember the exact number off the top of my head, but we have typically 9 to 10 grass species, another 5 or 6 forbs, and then we also included some shrubs in this mix as well. And we even included what we called shrub islands on these slopes to try and mimic the existing, the pre-construction landscape condition. And so, but we are monitoring the project monthly actually at this point still, and paying attention to what's coming on. But there's no base flows right now. We're seeing a lot of sediment movement though, especially with an active construction site still feeding a lot of these stormwater systems. We're seeing quite a bit of erosion hitting our channel. One thing, there is a trail right along the top here that is utilized all the time, and that's actually where we saw more erosion coming off of than anything in the stream was water coming off the trail and eroding down these very steep slopes. And so you can kind of see some little squiggles that we try to do here, and that's what just like got blown out by the contractor. They were like, what is that? This needs to be a straight 4-to-1, right? And these are long runs too, so that's where you really see some erosion, is there's zero interruption of these slopes. And so I think we have the potential to start to see more erosion there, but you know, we're getting better vegetation establishment, so I hope that we won't see too much moving forward. Yes, Nolan? Yeah, that's a little outside of my area of expertise. Let me look around the room here. Morgan was on the project when this was in design. I don't know if you want to take a stab at that. Anything else? Oh, yes. You may, since you asked so nicely. There's no river. No, it's just it was a dry watershed. Yeah, so there's no perennial flows through there. Willow Creek is over here on this side, and there are perennial flows there. Tyler, what is base flow, like 10 CFS? 5 CFS, yeah. So yeah, this is just all dry. It's only stormwater flows. So leaky irrigation that may be spraying on the sidewalks or streets, or only during storm events. There are storm outlets that enter into the channel. There's one here, and then it's just like surface runoff. So there's no perennial flow. Yep. So what they were trying to do is prevent any further incision in this drainage way, because this is the low point of the watershed for this area, right? And so as we increase the stormwater flows into this drainage, we would just see that continued down cutting. The head cut that was in the channel had been stable for, based on aerial imagery, 40 years or so. Like, it hadn't really moved much, but once you add all the urbanization around it and add flows in there, that's where we would have seen that continued incision. So we wanted to create a stable system that could handle that while still achieving those ecosystem functions that this type of system can provide. And this is going to flip back to that court case. I guess I do have time for it. The argument that they were making, and they monitored this gulch for, I think, 10 years, and they had it associated with a rain gauge too. And so the argument that they made was that even during big storm events, there was no flow in this channel. And so therefore, any stormwater that was then captured in, there's a big, so I don't know if you guys caught it, but here it says reservoir, right? There's marketing materials that showed like lakefront houses for this thing, right? There's no reservoir that actually exists here. Now it's a peak shaving pond is what we call it. But their argument was that any water that ended up in this gulch as a result of the development, they could store and then reuse as irrigation. They didn't end up doing that, but that was the argument they made, and that's what ultimately made its way all the way to the Supreme Court, state Supreme Court. And so yeah, there really is no real base flows for this. Only once the irrigation pipes start leaking or overspray of irrigation starts to flow into this will I think there'd be anything that would be a measurable base flow. Otherwise, it's all stormwater. Mm-hmm. You betcha. Yeah. Anything else? Thank you, guys. I really appreciate it. Big hand, too, to all the organizers for the conference, too. I don't know if they're going to get a chance to do that, but it's been great. If there's any organizers in here, thank you. See y'all soon.